Welcome to Summarize Science, where we dive into the latest research making the world a bit more efficient. Today, we are talking about how the humble tractor is becoming a high-tech autonomous machine. When farmers harvest hay or forage, the material is gathered into long lines called windrows. Keeping a massive tractor perfectly aligned with these rows for hours on end is exhausting and can lead to mistakes. This repetitive task is one of the biggest causes of operator fatigue during long harvest periods. While big companies have systems to help with this, their technology is usually a trade secret, making it hard for the rest of the scientific community to improve upon it. Researchers have now stepped in to bridge this gap by releasing an open-source dataset and a new detection method. They equipped a Fendt 724 tractor with various sensors, including a stereo camera and a high-end LiDAR unit. The platform records diverse field operations to capture what real farming workflows actually look like. LiDAR uses lasers to map out the environment in 3D, while stereo cameras use two lenses to perceive depth, much like human eyes. The team recorded a subset of data over 2 minutes long to see how well these sensors could find the center of a windrow. They used a weighted centroid approach to find the center of the crop row, which helps the system stay robust even if the hay is piled irregularly. This method is designed to ignore noise and focus on the highest points of the crop material. Using a powerful onboard computer called the NVIDIA Jetson AGX Orin, they process this data faster than 20 frames per second. This speed is crucial because a tractor needs to make split-second steering adjustments while moving through the field. In this visualization, you can see how the computer overlays the detected path directly onto the camera's view using both laser and camera data. The results show that the system achieved real-time performance without dropping any frames. One of the most surprising findings was that the low-cost stereo camera performed almost as well as the high-resolution LiDAR. In the critical range of 4 to 10 meters in front of the tractor, both sensors agreed on the row's center with over 96% accuracy. This means that future automated tractors might not need thousands of dollars in laser equipment to get the job done. While the camera's depth perception gets a bit fuzzy at long distances, it remains perfectly acceptable for guiding a tractor at typical speeds. To recap, these researchers have provided the first open dataset for this task and proved that real-time detection is possible on standard hardware. They showed that affordable cameras are a viable alternative to expensive lasers for following field rows. By sharing their code and data, they're inviting others to help build the future of GPS-free navigation in agriculture. This could eventually lead to fully autonomous harvesting systems that are cheaper and more accessible for farmers everywhere. It is a big step toward making high-tech farming more transparent and collaborative. Thanks for watching Summarize Science, and stay tuned for more breakthroughs in the world of technology.